going to, well, I'm going to, and you're going to watch. So that means you can't have phones out, you can't have any of that stuff. You're paying attention because this is very important that you understand how the heck a sine graph appears. You know, we've looked at them on your calculator and they've just appeared, and then we look for intersections. That's all we've really done before, correct? But what we can do is this unit circle is a wheel. Anything that's a wheel, so it repeats itself over and over and over, or a pendulum, which means it has a max, a min, a max, a min, a max, a min, a max, a min, and the max and the min stay the same, can be represented by a sine or a sinusoidal graph, which is a y equals sine x graph or a y equals cos x graph. Okay? So any type of wheel, because a wheel goes max, min, back to the same max, back to the same min, back to the same max, back to the same min, right? Or a pendulum, max to min, and same ones. You can do that. If you're given anything in that shape or form, you can make a sine graph or a cosine graph out of it, which are called sinusoidal functions. Okay? So what's in front of you? Your unit circle. Your unit circle is a circle. A circle has the same max and min. So we can represent that as a sinusoidal graph. You aren't doing this, you're just paying attention. So if you have a phone out, that's a problem. So this is 0. If I pick a pen, that's going to be a 0. Okay, so this is going to be 0 degrees, and then 30, 60, 90. So these are all going to go up by 30s, right? But I'm going to delay. So I'm going to go 30, 60, 90, and then 120, 150, 180, and then 270, and then 360, and then this would go negative 90, whatever. I'm going to write it off. We don't lose you. Okay, and then this would be negative 30, negative 60, negative 90, negative 120, oopsies, negative 150, negative 180, negative 210, negative 240, negative 270, negative 300, and I would just keep going. We agree? Yep. Okay, and then this would be 120, 150, 180, 210, 240. Okay, we agree, and I'll fill the rest in as I go along. We are going to draw the y equals sine x graph first. Our unit circle gives us every sine value, does it not? Yes. All the sine values are the what values of the coordinate? The y. So if I wanted a coordinate for the sine x graph, I would technically do like cos of, what? Sine, I don't even, what did I write it right there? Sine of 0 degrees. Oh, my Lanta. I would go 0 degrees and then sine of 0 degrees. We agree? That's how we got that outside coordinate? That's how we got, suppose. So, what is 0 and sine of 0? 0, and what is sine of 0 degrees? It's 0. We agree? Yeah. So this is 0 degrees, and sine of 0 is 0. Yes? And our next coordinate would be 30 degrees, and then sine of 30 degrees. So it's going to be 30 degrees and 1/2. Yeah, I'm right. Because we're doing an input-output, just like a t-table. You know, you did those in junior high even already. Your input is going to be your x, your output is going to be your y, and what does y happen to be? Sine x. So do you see how I'm inputting an x, I'm outputting a sine x? Right? Yeah? Okay. So if I plotted those points, first off, I would have 0, 0. And then I'm going to, I'll make it in blue. 0, 0. And then I'm going to make this be 0.25, 0.5. Why am I making this so small? 0.75,
because your unit circle only goes to 1.
Yeah. And to negative 1, right? So this would be negative 0.25, negative 0.5, negative 0.75, negative 1. Okay, so I'm at 0, 0, and then I'm at 30.5. We agree? 30 and 0.5? Now what falls between 30 and 60? Right in the middle. 45. Is 45 on my unit circle?
Yes.
Yes. So I could do 45 degrees and then sine of 45 degrees because I'm just inputting an input into my y. We agree? So it's 45 and then what? Root 2 over 2, which is 0.707 if you put it to a decimal, because I don't know what root 2 over 2 is on there to draw, right? But 0.707 I could do. So 45 falls right in the middle. So I go to there and 0.707. So I'm going to go to 45 and then 0.7, approximately there. Like I'm really just guessing. Okay? Then I go to 60 next. 60 degrees, and then sine of 60. What are we going to get? 60 and root 3 over 2, which is 0.8660. So I go to 60 and 0.8660, I don't know, like there. Like it's not the most accurate thing you see, right? Your calculator will spit it out for you, but I want to see how your calculator actually spits it out rather than you just have no idea. Okay? Then if I do, my next one would be 90, and then sine of 90. What's sine at 90?
1.
So now it's at 90 degrees and 1. So I'm here. Right? Do I have to keep writing sine of everything, or can we now figure out what the coordinates might be? Can we keep going? So if we go to 120, what's sine of 120? Root 3 over 2. So I'm at 120 and root 3 over 2, which is 0.8660, should be the same, right? Then if I do 135, light bulbs are hitting, this is good. 135, sine of 135 is? Root 2 over 2, 0.707, so symmetrical.
Look at that.
Ah, it's 135. Left.
It's crazy on that.
So 135 falls in the middle. So it's like here. And then 150, sine of 150 is a half. So I go to 150 and a half. Actually, my marker will join me. Okay. And then I do 180. 180 and what?
0.
0. Okay, now it's going to get a little more complicated. 210. Looks like I need to be hitting some negative y values. What is 210?
Negative.
Negative a half. Well, it's starting to look like it's working. And what's negative 225? Or sorry, 225. What's negative?
Negative root 2 over 2.
Negative root 2 over 2, so 0.707.
Yeah.
So that's going to fall in the middle, so 0.707. Then what's 240? Negative 0.866, right? What's 270?
Negative 1.
Negative 1. And then I have 300, and then 330. Okay, so then this, 300,
Negative root 3 over 2.
negative root 3 over 2. And then 315, 0.707. 330, negative a half. 360 is back to here. And then what's it going to keep doing?
Oh, that's
Right? It's just going to keep going. What about this way? Well, this one's going to be negative 0.5. Then negative 45 is negative 0.707. Then that's here. Oops. Then I'm going to get negative 0.8660. Then I'm going to get negative 1. Then this. Then 0.707. Then 0.5. Then 0. And then 0.5. Then 0.707. Then 0.8660. Then 1. So do you see? And it's not a mountain. When you put in your calculator, you'd see, shh, it's going to go like this. Now I'm going to make this one a different color. The red's just the unit circle, right? If I just pulled straight off the unit circle. And then it would just keep going, correct? Like if I wanted to, I'd keep drawing my graph and it would just keep going. Do you see that?
Yeah.
Everyone, that makes sense? So to get the sine x graph, we're technically using the angle on the inside of the circle and the y value of the coordinate. Because that's sine of 0, correct? Well, let's look at the cos. So the next page, well, for me. So I have 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, and it would just keep going. 390, 420, 420, 450, 480, 510. So I'm literally just adding 30. Right? That's all I'm doing. And then I would go this way. And then I have 0.25, 0.5, 0.75, 1, negative 0.25, negative 0.5, negative 0.75. Now, coast graph, often people will mess up because when you're using the y, you're actually making a sine graph. The y of a coast graph is actually the x of the coordinate, which messes people up because you want to use y's. So let's think about it as a coordinate. We're trying to draw the graph y equals cos x. So our input will be x, but our output will be cos x. Correct? So if our input is 0, our output is cos of 0, which is actually the x value of the coordinate. Correct? So people want to pull the y because y's always make a y. But actually cos of 0 is the x value of the unit circle coordinate. Right? So this is going to be 0 and what? What's cos of 0? Do you see how we're actually using the x value off the unit circle for a y? And that confuses people. And I get it. Okay? So now we have 0 and 1. Then I have to do cos, so I have to do 30. What's cos of 30? So it's 30 and then root 3 over 2. So it's that 0.8660. Then 45 falls in between, which is root 2 over 2. So 0.707. Then I have 60. What's cos of 60? 1/2. So you see how the x values of the unit circle are actually the y's of the cos graph? And that I know is hard to wrap your head around. But if you do input and output, it's not as bad. If you input 30 and your output is cos of 30, it's just you're doing t-tables, right? Just like junior high. It's nothing crazy. Then don't overthink the fact that it's the x of the unit circle, because we're not looking at the x of the unit circle, we're looking at cos of 30 is our y value. Okay? So then I'm at 60.5. 90 cos of 90 is 0. Cos of 120 is negative 1/2. Cos of 135 is 0.707. Cos of 150 is negative 0.8660. Cos of 180 is negative 1, then 0.866, then 0.7, then 1/2, then 0, then 1/2, then 0.70, which is down here, and then 0.8660, then 1, then this, then 0.707, then 1/2, then 0, then negative 1/2, then 0.707, then 0.8660, then negative 1, then this, then this, then this. You see what I'm doing? Like it's repeating itself. So if I go this way, it's the same thing. 8660, 0.707 in the middle, 0.5. This should be 90. What is this 120 here? Oh, this is going to be sad. I just did the whole thing. 90, this is 120, 150. Okay. And then this is going to drop 0.5, 0.707, 0.8660, negative 1, 0.8660, 0.707, 0.5, 0.5. So you end up with something like this. One second. part is the unit circle, right?
Yep.
Yeah, looking at.
So, if you were trying to figure out like an x-intercept, there would be like a horizontal line that passed through
9270.
the graph.
Yeah.
Okay.
It would be here. You'd use y equals 0, right? Because y equals 0 is the x-axis. If you wanted x-intercepts, you'd have to use y equals 0 as your second
Yeah,
equation.
so then, but if this is x, because these are x values.
These are not x values. These are y values. They're x values off your unit circle. Those are all y values. Cos of 30 is a y value. You want to pull the answer off the x of your unit circle. It's not an x value. This is an x. This is a y. Coordinates are always x, y. X, y, x, y. So if you want the x-intercepts, you literally go to your graph and say negative 90, 90, 270. Literally list the x-intercepts. That's a graph of the next x. So this thing repeats itself every 360, which makes sense because your unit circle repeats itself every 360. Okay, I want you to do this. Go to your calculator, and in y1, you're going to type sine x. And then if you have a colored calculator in y2, you're going to type cos x. But make it thicker if you don't have the colored calculator. What mode do we want to be in? I put us all in degrees. It just doesn't matter right now. Degrees are often easier. And then you go to your window, and your x minimum, I would make be negative 360. My x max, I would make 360. And then I would make my x scale be 30 degrees, because that's what I made these all be. What should my y max be? We can make it be 1. Do we want to make it be a little higher so that we can actually see the maximum? Yeah, so I'd go like 1.5. I should do min first, sorry. Y min is negative 1.5. Y max 1.5. Y scale 0.25. And plug it in. In front of you, you have a sine x graph and a cos x graph. So you have something that looks like this is a cos, and then you also have a sine on there. So you have this, 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 this. Yeah. So you have a graph that looks like this. The green one is the sine x graph, right?
Yes.
And I could keep drawing it. You could go like this, go like this, there, 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 etc. Okay, so the green graph here is my sine x graph, yes?
Yeah.
The reddish purpley one, I got a couple colors going on there, is the cos x graph, yeah? Can I make them be each other?
Yeah, you probably.
Are they the exact same graph, just started later or earlier or
Yes.
something like that? You see how they're the exact same graphs, they're just a horizontal shift from each other? So if I go to make a sine equation or a cos equation from this graph, my A and my B and my D are all going to be the same. The only thing that's different is a horizontal shift. So let's try it out. I want to make, let me use the yellow. I want to make the sine x graph, I want to do something to the sine x graph to make it be the cos x. So I want to move this somehow horizontally, so it's going to land on my cos. What am I going to do?
Horizontal translation 390 units.
So many things going on right there. You were close. So you had right things in there and then a couple extra threes. So if I take this sine x graph and I move it 90 to the left, it should land on the cos graph, shouldn't it? Do we agree? You just had some extra 3 numbers in there, but that's totally fine. You got there. You got there. That's all that matters. So instead, these were the equations I told you to write. Well, if I want to get the sine to land on the cos, I'm going to change this one to not be sine. I'm going to change it to be sine x. I want to go 90 to the left is what we said, correct?
Yes.
How do I, yes, plus 90. So now type that one in with the coast being it. And then you should get the same graph. Yeah, horizontal translations are opposite. Did they land on the same spot? So really, coast and sine graphs are a 90-degree shift from each other. So if I wanted to make the coast land on the sine, I would just move it 90 to the right instead, right? I would go x minus 90 and keep sine x being sine x. And then they would land on each other. That's it, right? Nothing crazy. Do we agree? All right. Now I want you to go to the booklet that I just handed you in front of your face. It looks like this. Chapter 5 is all about graphs. All right. Quiet, please. So we're going to look at these equations. We'll come back to this information up here in a second. We're going to look at these equations right now. So the graphs we did before this were y equals sine x and y equals cos x graphs, right? And they just were a 90-degree shift from each other. You guys agreed with me. Or a pi over 2 radian shift, right? From each other. What was the highest they went to? 1. What was the lowest they went to? Negative 1, correct? Now, if I go to transformations, which is what we're going to use in this unit, what's the only thing I could do that would change that? What are some transformations I could do that would move me from negative 1 to 1 to something else? Vertical stretch would take that and go like this. Or, so I can make it way more narrow or way wide, correct?
Yeah.
That would change my range. What else would change my range? Would a reflection?
Yes.
No.
It would just go negative 1, 1, right? Okay, what else could I do? Or vertically? Vertical translation, which in Chapter 5 we actually call the vertical displacement. It's only a trait that it changes. You're welcome. You can't write as translation, it's wrong. So, vertical displacement could move it completely up or completely down, right? So if I was at negative 1, 1 and I moved it up, it's not going to be negative 1, 1 anymore, right? So that could change the range. Now, the period of the graph is 2 pi, okay, or 360, because it falls off the unit circle, and the unit circle is 360. We agree, right? What's the only thing that could change that period? Horizontal stretch. If I stretch it by 2, now instead of it repeating itself every 360, it's going to repeat itself every 720. If I horizontally stretch it by a half, instead of repeating itself every 360, it's going to repeat itself every 180, right? So a horizontal stretch will change the period of the graph. The period is how long it takes to repeat itself. So that's off of an actual graph, okay? What about an equation? So we're going to talk about amplitude. You don't have to write this, it's all up here. But the amplitude is actually half the vertical distance. So you can write that. Once I get a pen. Amplitude, at the top of your notes. It is half the vertical distance. And because it's a distance, it's always what, do you think?
Positive.
Yes. Because displacement can be negative, but distance can't. So it's half the vertical distance. So if we go back to that sine graph and that cos graph, what's my vertical distance? Of the sine graph and cos graph I just drew? 2. So what's half of that? 1. So the amplitude of those previous graphs were 1, right? And what's the only thing that can change an amplitude? Vertical stretch. You can make it wider or narrower, correct?
Yep.
Your vertical stretch is actually your amplitude. How would that be the case? Well, our sine and cosine graphs go from negative 1 to 1. So what's the only thing that can change a number? Vertical stretch, right? If I multiply it by 3, it's now 3 to negative 3, is it not? So that would make that a distance of 6. What's the amplitude? 3, because it's half the distance. So I can use this formula to figure out the amplitude off of a graph. So if I'm given a graph, I can do the absolute value of the max minus the min divided by 2. I can use that formula. It's an absolute value because amplitude has to be positive. correct? Or I could literally just count the vertical distance and divide it by 2. Because that formula does that. It just makes you get the vertical distance on the top, and then it divides it by 2. That's all the formula does. Okay? Off of an equation, the absolute value of A is actually your amplitude. So off of here, if I'm going at a graph, I'm going to use that formula, or count, and divide by 2. Correct? If it's off of an equation, so these are my equations, it's just the amplitude is the absolute value of A. Because the reflection doesn't change how high or low I go. Yeah. So off of a graph, I can use the formula, or I can count and divide by 2. Off of an equation, it's literally just vertical stretch. Because the absolute value of A is just the vertical stretch, is it not? So your amplitude is equivalent to your vertical stretch, which makes sense. -1 to 1, if I'm stretching, it changes my amplitude, right? Because it's half that distance. So we're just going to talk about amplitudes for a second here on these equations down here. So these two equations here, what would my amplitude be of A? It's 2. These are absolute value signs. This is not the number 121. Absolute value of 2 is 2. Correct? Because it's going to take that -1 and it's going to make it be now what? Negative 1 is going to now become what? It's a vertical stretch by a factor of 2, guys, right? -2. And my positive 1 is going to become 2. And what's -2 to 2? 4. And what's half of that? 2, which is my amplitude. It's the absolute value of A. You just remember that, you're good. So what's the amplitude of this one? A half. All right. We talked about the period of a graph, and the only thing that could change the period of the graph is what? Horizontal stretch. We agree? So if my graph had a period of 360, which it normally does, or 2 pi, and I horizontally stretched it by 2, what would it now be? 720. If I stretch it by a half, it's now 180. We agree with that, right? All right. Off of an equation, we can also just use this formula. We could do 2 pi divided by the absolute value of B, or 360 divided by B, remembering that B is just in here. But how the heck does that happen? No, you don't. Yeah. So, if our B, let's look at this, for this one. If our B is 3, do you see it? Our B here is a 3. The B is the period. The period gets you nothing. The period is useless. The period is useless by itself. But if I use the formula, it's not useless. So period equals 360 degrees divided by the absolute value of B. What's B in this case? 3. So I get 120 degrees. Now, what if I do it using the horizontal stretch instead? Remember, we were just multiplying it by the horizontal stretch and we were getting our answers. So let's see. P equals 360 degrees times the horizontal stretch. What's my horizontal stretch in this equation?
3.
No. What's my horizontal stretch? No. 1/3. What do you do with your B? Flip it, flip it, flip it, flip it, flip it to get your horizontal stretch. We agree? So what is my horizontal stretch? Well, it's 1/3. What's 360 times 1/3? 120. So that's why this formula works. If I divide by B, what's that the same as? Multiplying by 1 over B. Right? So let's look at that formula up here. If I take the period equals 2 pi divided by b, that's the same as saying 2 pi times 1 over b, is it not?
Yes.
Because when you divide by something, you multiply by the reciprocal.
Yes.
So I can either divide by the b value of my equation, or I can actually multiply by the horizontal stretch. Because the horizontal stretch is 1 over b, right? So I can either divide by b or multiply by the horizontal stretch. Either way, I'll get the same answer. True? True. So, what's the period of this one? So I can either do 360 degrees divided by the b value. What's the b value? 1/2. Or I can do 360 times the horizontal stretch, which is 2. Either way, I type that in or I type that in, I get 720 degrees. Right? These are numbered terribly, just so you know. It's 1, 4, then 5 on the back. I don't know why it's not 1, 2, 3. For these questions right now, I just want you to give me the amplitude and period. So for 1, I want the amplitude period. 4, I want the amplitude period. And 5 on the back, just the amplitude and period. So go give me those. Amplitude should be easy for given equation. What's the amplitude of this one? It's 2. It's just my absolute value of my A value. What's the period of this one? No, that's the period. So B is 1. What is the period?
360.
360, because we can go 360 degrees divided by 1, which is 360. Also knowing we don't have a horizontal stretch, so it's not getting any wider or narrower. Or in radians, 2 pi divided by 1, which is 2 pi. We're going to write both of them. Okay, what's the amplitude of this one? It's a 1. If there's nothing there, it's a 1. Some people are like, well, it could be a 0. What's 0 times anything?
0.
0, so it can't be a 0. It has to be
Why
a 1.
change my answer?
So the amplitude is 1. The period, some people say, is 360. No. The period is 3, which is not the period, or it would start with a P. So the period is 360 divided by 3, so it's 120 degrees. Or I could ask for it in radians. So it would be 2 pi divided by 3, which you're done, because that is 120. Okay? And 5, what's my amplitude? 1. And then what's the period? Well, this is B. B equals 1/2, so that is not the period. The period is 360 divided by B,
720.
which is 720. Or 2 pi divided by 1/2, which is 4 pi. Or you could consider it as a horizontal stretch, right? I'm horizontally stretching it by 2, so 360 is becoming 720, 2 pi is becoming 4 pi. Because the horizontal stretch will be what actually changes it. And when we divide by b, the reason why dividing by b works is because dividing by b is multiplying by its reciprocal, which is the horizontal stretch. You are actually multiplying by the horizontal stretch every time you're dividing by b. Because dividing by b makes you flip it, aka multiplying by the horizontal stretch. Okay? Now, what are the transformations? Well, the only thing I have happening here is a 2. What kind of transformation is that? Vertical stretch by a factor of by a factor of 2 about the x-axis. Vertical stretches only apply to vertical things, correct? To things that have y's, right? Because remember when you do mapping, it would affect your y things, right? Is amplitude y values or x values?
Why?
It's y's, right? Normally your basic amplitude is from -1 to 1. So would a vertical stretch affect that? Yes. Would the range change? Yeah, because now it's going to be -2 to 2. Would the period change?
No.
No, because that's the next thing. Would the domain change? No, that's the next thing. Would the x-intercept change? No, that's the next thing. Would the y-intercept change?
Yeah.
Yes, that's a y thing.
Let's go.
Assume it's easy.
Perfect.
Challenge.
Uh-huh.
God.
What is this? This is, he's in about 2 days, he's gonna be like, everything sucks, I don't understand anything, I'm gonna fail this test.
You know what? I won't.
Okay. Based off of past talk, I would say that's where we're gonna end up. Horizontal Wednesday. I give him Wednesday, maybe Thursday. Horizontal stretch
What do I get when I don't
Nope.
struggle?
by a factor. I hope you don't struggle. I'm not gonna bet you won't struggle. Horizontal stretch, and often you think you don't know what you're doing, you do. So
That's false.
horizontal stretch by a factor of what? Yeah, 1/3 about the y-axis. And because it's a horizontal thing, it affects horizontal things, all the x things. Amplitude is the next thing? No? No, it's a y thing. Range? A y thing. Does the period get affected? That's an x thing, so yes. Domain is faulty. It's not affected, even though it is an x thing. What's the domain of a sine graph and a cosine graph?
Infinite.
Infinite. Does anything affect infinite? No. X-intercepts? Yes. Y-intercept? No. So technically domain does normally get affected, it's just that it's XER. That's why it doesn't get affected. Okay? Okay. This one is a horizontal stretch. By a factor of what?
3.
What? Not even a 3 in the question. There's not even a 3 in the question. Horizontal stretch by a factor of 2. Scares me a little bit. About the horizontal. It's about the
I wasn't looking at the question.
amplitude. No, affects y. Range. No, affects y. Period. Yes. Domain's never affected. It's XER. X-intercept. Yes. Y-intercept. No.
I'm still on the last equation.
It's simpatico.
Answer. What's the amplitude of this one? What's the amplitude? 3. What's the amplitude of this one? Number 2. Amplitude of 3. 3. What's the amplitude of 4? Amplitude is always positive. Amplitude is your vertical stretch, right? Not your vertical stretch and your reflection. So amplitude is always positive. It's a distance. Horizontal stretch factor of number 1. 1/2, because Noah's flips. And then 2 is? 1/3. 3 is? 2. 4 is? 4. So, if my horizontal stretch factor is between 0 and 1, the period is getting smaller, right? So horizontal stretch factor is greater than 1, your period is getting larger. You're taking 2 pi and you're stretching it by that much, right? Now, this one, I know it's going to be a 180 or pi. But what you can do is you can still use the formula if you're stuck. 360 divided by the absolute value of b. Absolute value of b, because if there's a reflection, you do not use the negative. Period goes positive. And then 2 pi divided by the absolute value of b. So we could go 360 divided by 1/2, which is actually, sorry, divided by 2. Wow. Why are we dividing by 2 and not 1/2? Because it's b. So we would get 180 degrees. Or we can do 360 times the horizontal stretch, which is 1/2, which is still 180. Correct? When you're using that formula, you are using b, not the horizontal stretch factor. You are using b. If you use the horizontal stretch factor, you just multiply. Right? If your horizontal stretch factor is 2, it's becoming 720 because you're multiplying by 2. Right? You would divide by 1/2, which would make it 2. So if you're using the formula, what's in the formula? B. And what is B? This number, this number, this number, this number. That is B. Correct? If you're using the horizontal stretch factor, you are multiplying. You just multiply your pi. So see, if I'm using the formula, I'm going to divide by 2. This is the formula. Great. Glad. Oh my gosh. I use the formula. I divide by 2. This is if I use the horizontal stretch. I multiply. So this one's going to be 360 divided by 3. If I use the b, which is 120 degrees. Or I can use the horizontal stretch factor and go 360 times a third, which is 120 degrees. Right? So it just depends on which version you use. This one I can go 360 divided by b. b is a half. So I'm getting 720 degrees. Or I can use the horizontal stretch factor and go 360 times 2, which is 720 degrees. This one I can go 360 divided by b, which is a quarter, which gets me 1440. Or I can go 360 times my vertical stretch factor, or my horizontal stretch factor, and get 1440. Now, just so you know, I'm only giving you homework on this and the next lesson when they're together. But I posted your chapter 6 Candid, and it is due Friday. So I would start working on that tonight. It is on chapter 6, which is verifying, proofs, restrictions, addition and subtraction formulas, right? Solving.
No, it's actually, it's Wednesday